focused on section 4.1, which is basic graphs. So let's get right into it. So this is a graph of the sine function. And as you can see, it starts at 0, and then at pi over 2, it goes to 1, back to 0 at pi. At 3/2 pi, it goes to -1, and back to 2 pi, which is 0. All right. The cosine graph starts at the 1, then it goes to 0, then it goes to -1, and then 0, and then back to 1. Tangent looks like this. There's asymptotes at negative pi over 2 and positive pi over 2, and the graph will look, it'll curve up that way. Notice there's no defined amplitude because it continues to go up as indefinitely and also goes down indefinitely. And cosecant is a reciprocal of sine. So what you would do is you'd first graph sine, and you would do a dashed graph, and then you would do this cosecant graphs, which are these curves that look like that. And same thing with the secant. For the secant, you would first graph cosine, dotted it, and then you would draw these curves, and that is a secant graph. And cotangent looks like tangent, except the asymptotes are at 0 and at pi, and instead of going upward towards the right, like tangent, it goes upwards towards the left. All right, and then there's a difference between even versus odd. Cosine is considered even because if you take the cosine of a negative argument, it turns out to be the same thing as the cosine of the positive argument. So for example, cosine of negative pi over 6 is going to be the same thing as cosine as positive pi over 6 because it's an even function, and that value would be radical 3 over 2 for both of them. Whereas sine is considered an odd function, so even for cosine, odd for sine. And what that means is that sine is going, the sine of a negative argument is going to equal to the negative of the sine of the positive of the argument. So for example, the sine of negative pi over 6, because it's an odd function, is equal to negative sine of positive pi over 6, which we know is 1/2 times a negative. This is equal to 1/2, but then times a -1 is negative 1/2. All right, so the way that affects the graph is if the function is odd, then there's origin symmetry. So there it is, origin symmetry. So sine is odd. As you can see, it's symmetric about the origin. This point is symmetrical to this point over the origin. So on and so on. This point is symmetric to that point over the origin. Any point that you can find you could find its corresponding reflective point over the origin. Whereas cosine is, we said, is y-axis symmetry because it's even. So any even function will have y-axis symmetry, so it's symmetric over this axis. As you can see, this is a mirror reflection of that over the y-axis. All right, so here's an example. Let's go ahead and apply the rule. Since cosine is even, we know that cosine is of negative 2/3 pi is going to be equal to positive cosine of positive 2/3 pi. All right, and if you don't know the value of cosine of 2/3 pi, you would look at your unit circle and see that 2/3 pi is here. Cosine is equal to the x coordinate, so that would be -1/2, -1/2. And then the cosecant of -225 is the same thing as 1 over sine of -225 degrees. And since sine is odd, that means that that's equal to 1 over negative sine of positive 225 degrees. And we can look at a unit circle again. 225 would be right in here. It's this angle, right in between these two. It's not listed here, but you could always fill it in yourselves. And the sine would be this value. So negative radical 2 over 2. But there's a negative there, so a negative of a negative is positive. So it's going to be 1 over positive radical 2 over 2, which is 2 over radical 2. That does it. Now let's go ahead and move over to the homework. So let's look at the first problem here. These are fill in the blanks. Let's go to number 4. It says, which trigonometric functions have a defined amplitude? So the amplitude of a function is how high the function reaches the top and how low it goes. So the amplitude is the midpoint between this highest value and the lowest value. So the max, half of the max minus the min, absolute value of that actually, because it's the amplitude is always positive. So here's a formula. Amplitude is going to be 1/2 the absolute value of the max minus the min. All right, so this would be the maximum height, the minimum height. So if you subtract that and divide by 2, that gives you the amplitude. So it turns out that just sine and cosine have a well-defined amplitude. All right, let's fill out the table for this. We're looking for cosecant of pi over 4, or actually for all these individual values. All right, so for sine, this is 1 over sine, remember? Cosecant is 1 over sine. So let's, at 0, well, the sine of 0 is 0, so 1 over 0 is undefined. The next one would be pi over 4. Well, that would be 1 over radical 2 over 2, which is 2 over radical 2. Which you shouldn't have to rationalize, but you could actually. If you did rationalize it, it would be radical 2, as you will see. So Webb sign will mark that correct, but you could also rationalize the denominator. Let's just do a couple more of these. Let's do pi over 2. So the sine of pi over 2 is 1, so 1 over 1 is 1. All right, let's just do one more. Let's do 7/4 pi. So 1 over sine of 7/4 pi. 7/4 pi is way over here. So the sine would be negative radical 2 over 2. So that's going to be negative radical 2 over 2, which is a reciprocal, which is negative 2 over radical 2. And if you rationalize that, that's going to be negative radical 2. If you rationalize that, which it is. All right, so the graph, once you have all these values filled out, then you will see what the graph would look like. And so the graph will be, let's see, at pi over 2, it's going to be 1. Pi over 2, this one's clearly wrong because that's negative 1. It should be up here. So this one's out. Pi over 2, it should be 1. Pi over 2, this is an undefined asymptote, so it can't be that one. And at pi over 2, it is 1. Pi over 2 asymptote, so it's got to be this one. All right. Same thing goes for this one. Let's just do a couple of these. The tangent of 0 would be, tangent, if you recall, is equal to y over x. So at 0, you have 0 over 1. 0 divided by 1 is 0. So this would be 0. At pi over 4, it's going to be radical 2 over 2. So if you divide that divided by that, you get 1. For the next one, pi over 2, if you look at pi over 2, there's pi over 2. Y divided by x is 1 over 0. That's undefined. Let's do maybe one more or two more. 3/4 pi. If you look at 3/4 pi, it's going to be right there. That y divided by x is negative 1. All right, and you would just continue to do that. And if you look at these values here, the two asymptotes are going to be at 0 and pi. I'm sorry, at pi over 2 and 3/2 pi. That's where the two asymptotes are going to be because that's where it's undefined. So pi over 2 and 3/2 pi is where tangent is undefined. So it looks like this one could be it. This one cannot be it because at pi, the value at pi, oh, we didn't do that one yet. At pi, y divided by x is 0. So this one's 0. So pi it should be 0, so it can't be that one. This one is potentially could be this one. It can't be that one. So it's got to be between this one and this one because pi is 0 and pi is 0. But at 3/4 pi, it should be -1. So 3/4 pi, it is -1. At 3/4 pi, this is +1. So this one is out. It's got to be this one. All right, they want us to sketch the graph of this following function, cosine, where x is equal to -4 pi. Okay, so they want us to graph between these two intervals. All right, so cosine looks like this. So I'll just go to 2 pi. So when x is 0, cosine of 0 is 1. Cosine of pi over 2 is 0. If you look at your unit circles, cosine of pi is -1. So it would be down here. And then at 3/2 pi, it's 0. And then at 2 pi, it's 1 again. So it's going to look like this. And since they want us to go all the way to 4 pi and to -4 pi, then you would just extend that out in both directions. So you would basically copy and paste and continue that. So maybe about here somewhere. Let's see. 1/2 pi, pi, 3/2 pi, 4 pi. All right, so then you would just go back to 0, back to -1, back to 0, back to +1. So literally just copy and paste. And you would do the same thing in this direction. You would extend this out, and then you would go -pi over 2, -pi, -3/2 pi, so on and so on. And then it goes back to 0, back to -1, back to 0. And I'm running out of space, but you guys get the idea. You would just extend it in both directions. So let's see which of these choices it would be. So we said at 0 it should be 1. At 0 it should be 1. At 0 it should be 1. So this is the only choice. This is not here. It's got to be that one. All right. Use a graph to find all of the values of x between 0 and 2 pi for which the following is true. All right. So where on the unit circle does sine have a value of 1? Well, there's only one value right here, pi over 2. So that would be pi over 2. All right. Which values have a tangent of 0? Well, tangent of 0 would be y over x would be 0 here. So that's 0 and 2 pi. And also here, y divided by x is also 0. So 0, pi, and 2 pi. 0, pi, and 2 pi. All right, last one. Which values have a secant of +1? Well, secant is the reciprocal of cosine, so we're looking for when is this equal to 1, for what angles? Well, if you look at your unit circle, we're looking for when cosine is 1, so that would be at 0 or 2 pi. And that would be it, 0 and 2 pi. That's the only time that cosecant would be +1. So